Okay, I got 10 shirts, 6 pairs of pants, 3 pairs of shoes. How many different types of outfits can be created? So we have 3 groups, and we are picking one of each. Okay. Pick one of each. Okay, so that's going to be the counting principle. Okay, counting principle. Well, first group 10, you pick one of those. First group has 6, you're only picking one of those, so 1 factor of 6, and then times 3. 10 times 8 times 3, 10 times 6 times 3 is 180. So, possible outfits. Okay, number 2. There are 10 people in spelling bee. How many first through 10th place finishes are possible? This one, there's only one group. Okay. So we do our have, take. We have 10, and we're taking them all, first through 10th place. So that's just 10 factorial. So 10 times 9 times 8 times 7, 6, 5 times 4 times 3 times 2 times 1. Okay, 3,628,800. Possible orders. Okay, number 3, there are 25 people in a shot put competition. Points are given for first place, second place, and third place. How many combinations of first, second, and third place finishes are possible? Okay, so we have take. Okay, again, because it's just one group that you're picking from. 25 people in that one group, and we are taking 3. Now look for those words. Oh, there they are, first, second, third. That means you are ordering them, ordered. So if they're ordered, you use the P, the permutation, and then 25 on one side, 3 on the other. So you subtract those, you get 22. Now you're going to circle the 3 because we don't use that in our division. When I circle it, that means, okay, protect it. So 25 factorial divided by 22 factorial. It's 25 times 24 times 23 times 22, and the 22 factorials cancel. Okay, 13,800 possible orders again. P is possible orders. Okay, number 4, there are 40 competitors in a high jump competition. The top 5 finishers make the state tournament. How many combinations of state tournament qualifiers are possible? Again, I don't care who got first, second, third, fourth, fifth here when I'm picking my group of 5. Okay, so it's one group. So then have and take. Okay, so we have 40, and we will be taking 5. Now, I don't see first, second, third, fourth, fifth, so the 5 I'm going to take are not ordered. Yeah, I don't put those in ordered. Okay. I mean, yeah, the person keeping track would, but I don't have to. I don't see first, second, third, fourth, fifth. It never says that. Doesn't say it. Okay. So P. So you put 40 and then 5. Okay. And then 35. By the way, number 3, I shouldn't have wrote combinations. It just said how many orders are possible. Or no. Sorry, I screwed that up, okay? They're not ordered, you use the C. That's on me. Not ordered is C. So 40 and 5. Sorry about that. Got sidetracked up there. Looking at how poorly that one was written. I forgot that it's going to be C. So you don't circle anything. So you take the 40 factorial divided by both the 35 and the 5 factorial. So we factor down the 40 till we're at 35. The 35s cancel, and then 5, 4, 3, 2, 1. Okay, so you parenthesize those. Divided by 5, 4, 3, 2, 1. Okay. 658,008. And when I use C, that's combinations. Okay. I'm not sure how this problem got in here. Don't worry about it. Okay. Find the three trig ratios for the angle theta is what that's supposed to say. Okay, so you got to use your SOHCAHTOA. So sine, cosine, tangent. Now, where's O, A, and H at? So the opposite here is always the H. So we know H is 16. Now we got to put what our reference angle is. And it's theta. Okay. So go opposite that, and that's your O. And then A is the third one. Okay, so these are, I just got to figure out these ratios, because ratio, OH, AH, and then OA. So obviously we need to find out the values for that. Well, we have H is 16, okay? And then O is 5. We just got to find that A, so I can fill this out and fill that out. So I pretty much know my sine ratio, okay? Okay, so if I just have to find that A value, I'm using Pythagorean Theorem. So in the Pythagorean Theorem, we know that A squared plus O squared equals H squared. Okay, so A is the one we don't know, so that stays as a variable. O is 5, 5 to the second power. H is 16 to the second power. So 5 to the second, 5 times 5, 16 times 16. So that's 25, and that's 256. Okay, so we replace 5 to the second with 25, 16 to the second, 256. Then we solve, these are on opposite sides, so you get rid of the 25. That's 231. Okay, apply a square root. Remember, that could be positive or negative, but over here we're just going to put positive, because when you're measuring side length, you don't want to put the negative. Okay, the square root of 231, that's IRR. So you put the division sign and you make your product of two square roots. So 225, nope. 196, nope. 169, nope. 144, nope. 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 Nope, this is fun. Okay, nope. Nope, so I guess it's 1 and 231. Okay, so square root of 1's 1. Okay, so we don't need the 1 factor, it's just the square root of 231. Okay, so A, the square root of 231, so then A here is the square root of 231, and that's my cosine, and then A here is the square root of 231. You can just leave it like that, you don't have to rationalize the denominator. Okay. Find the measure of theta. Okay, so you're trying to figure out how many degrees are within the theta angle. So sine, so, ka, toa, so sine, cosine, tangent. Okay. All right, H. Don't have that, that's fine, but we at least know where the hypotenuse is at. Now the reference angle again is the theta symbol. So that is my O. My O is 19. Then my A has a value of 16. Now, you don't need to find what H is, so don't set up the Pythagorean Theorem, okay? So to find the theta, you're going to set up a ratio. And you always want to put whatever the reference angle is here. It's not a variable, okay? It's just theta. Now, I got to decide what one of the three functions I'm going to use. Well, I know that A is 16, and I know that O is 19. So A and O would be the tangent function. And that is O in the numerator with A in the denominator. So we know O is 19, okay, and A is 16. So you don't cross multiply and divide. There's no letter. There's no variable to solve for, okay? You take out the 1 and you take out the tangent and move tangent over here as an inverse tangent, okay? So then theta equals the inverse of tangent of 19/16. So second tan 19 ABC 16. I got 49.89, 49.90. If you want to put 50, that's fine too. Okay. Okay, and here's the last problem here. Find 3 angle measurements and 3 side measurements of the triangle. Okay, so ka, toa. So sine, cosine, tangent. Okay. Okay, so the H is unknown. Now the reference angle is not theta, it's an actual degree measurement. It's 24 degrees. You can't ever use 90 as your reference angle. Okay, don't ever do that. So O, don't know. We have the A at 15. So on the sides, it'd be O, A, and H. And we know that A is 15. Okay. Okay, well, I have to find these sides, and when there's 2 of them you don't know, you can't use the Pythagorean. You have to use proportions. Okay, so I'm going to solve for O here and H here, but you have to remember, we know the value of A, so we need to use O with A and H with A, because I'm going to put that 15 on the ratio somewhere. Okay. Okay, so 1 put in the parentheses, 1 put in, and you don't use theta, you use the 24 degrees. That's your reference. Okay, 24 degrees instead of theta. So O and A would be tangent. So tan. And O's in the numerator, A's in the denominator. Now we don't know O, but we know A. So O is going to equal the cross multiplication and division of this. So I will take tan 24 times the 15 and then divide by 1. Okay. Okay, 6.68. There's your O side. Now the H and A, that would be your cosine function. And that's A in the numerator, H in the denominator. You don't go by the order you wrote it here. You go by up there. That's why that always should be there. Okay, A I know is 15, and H is what I'm trying to figure out. So H equals, so I'm going to now take 1 times 15 and then divide that product by the cosine of 24 degrees. It can be done on a calculator. Okay, so 1 times 15, that's 15. Then you take 15 divided by the cosine of 24 degrees. 16.42. There's the H. Remember, H should be the longest of the 3 sides. Okay, O and A, sometimes O is longer than A, sometimes A is longer than O. That's not in any particular order, but the H has to be the highest value. Hypotenuse is always the longest side. And the angles, you know, you have a 90 and a 24. 90 degrees, 24 degrees, and then remember, these add up to 180, so it's 180 minus 90 minus 24. Okay, and that's going to be 66 degrees. Okay,